We saw a few aspects in calculating probability and it was interesting. Means we start from analyzing the problem domain and then in depth we did the analysis. So if you are doing analysis of a problem and it is taking time, then you are lucky. Means analyzing problem is the most crucial thing in calculating the probability. Once problem is analyzed nicely, then you are picking the active. So whatever we see as problem, probably it is kind of only superficial, surfacial. Okay. When you go in depth and you look into the kind of problem descriptions and what is required, then you think about the actor. Now, when you think about the actor, then you think about the kind of sample space. So, in sample space, what are the items would be filled? Once sample space is kind of finalized, then you pick items from the sample space, and that is what you want. I mean, whatever you want, that you pick from the sample space. Analyze the problem, look for the actor, create the sample space of the items, and what you want, just pick here and there, divided by your sample space of the item. So, sample space, whatever you have the scenario, I would say problem space or the scenario. So sample space would not be the kind of same thing, so it would differ. Like we saw in examples, like if I have 3 balls, that is kind of a problem or that is a scenario. Okay, but from actor's perspective, 2 balls are required. Okay, that changes the sample space completely. Okay, where two balls are placed. If actor is at one time 3 balls are picked, sample space change. Doesn't matter what is the scenario that 2 balls are red and 3 balls are green and 2 are blue, whatsoever. Doesn't matter. So what matters is what is the decisive factor, what we want. Okay, so like if I am kind of flipping or tossing a coin, then coin, I am tossing coin is only one in my hand, and I am tossing it 2 times, 3 times, 4 times. So that is the crucial. That decides what would be the sample space and how items would look. Then we just think about how many or what are those items that we need to pick. Okay, so now we will proceed on kind of bias theorem. So bias theorem comes as important when we kind of think about 2 orthogonal items, not one item, 2 orthogonal items. Okay, so that is bias theorem. Like as we kind of described that there are people who talk English in the world. And if I say that there are people who talk English in the world, and then kind of the intersection of the Egyptian people and English people, means people who talk Egyptian and English, so those are kind of 1% of the world. So that is not what we are doing. So we are looking at 2 kind of items that are orthogonal. 10% of people talk English in the world, and 1% of the people, means all these data are fictitious, just to kind of demonstrate the bias theorem. So 10% people talk English in the world, and 1% of the people in the world are Egyptian, so they are completely unrelated. So 2 unrelated items now comes into the picture, and if I know each one's probability and the probability of any one against other, like if I say that I know what is the probability that if I know that if people are talking in English, then he is a English speaking Egyptian. Okay, so condition is that if a person is talking English, so that is the condition, then he is English speaking Egyptian. Or orthogonal can be, we gave example like there are two cars in at a place or a city, and one is blue and one is green, and now in accident the person who witnessed the accident, he said it is blue, but he can identify true only 80% of the time. Then, like if I talk about if 15% cars are blue and 85% cars are red, and there was accident, then what is the chance that a blue taxi made the accident? So that is 15 by 100. But now, so this is kind of a normal scenario. But in kind of little advanced scenario, now either a person saw the taxi who made the kind of a hit and run case accident, or we can just place a scenario that in that life the probability of the chance of finding the correct taxi is only 80%. What is the act? Now, what is the condition what is the probability that blue car made the accident? 15% cars are blue. And if someone is kind of a witness, he witnessing the blue car made the accident or hit and run, then what is the probability that actually blue car kind of it is involved in hit and run case? Okay. So first, who is there? Okay. So actor is the eyewitness, means because if it is 80%, then analysis, whatever sample space we are making, that will change. If it is making 90%, if it is making 50%, 40%, irrespective of exact amount of blue car and red car, things are varying as per the actor. Okay, so that kind of dynamic situation in probability. So that we'll see. So we'll see Bayes theorem, and Bayes theorem is important in kind of machine learning area where NLP like natural language processing. So there Bayes theorem is important. Like if I have to find like a document belongs to which category, like if I have a book and I can kind of parse the words or sentences, then I should be able to say that this book is kind of, it belongs to kind of some literature or some kind of a thriller. Okay, so this kind of thing we can guess. So that is again probability, and it belongs to here or there. So that we'll see in future NLP when we see the machine learning. So now we'll see the Bayes theorem. Okay, so we'll proceed on Bayes theorem. So that is the idea. Okay, so we'll include the slides for the Bayes theorem. Okay, so now if we see the scenario we presented, like if this is the case where we have items, then if we create the sample space of the items, then we may not select everything, and we select whatever is matching to the scenario, and then we pick whatever is required and we calculate the probability. So this leads to kind of a Bayes theorem. Okay. So what is Bayes theorem? Like if there are two items A and there is another item B. Now if I say if A is the condition, then what is the probability? So can we see the coloring? So B is kind of this color, okay, so reddish color, and this is white color. So now we can say that how much is reddish inside A. So if A is the condition, if A is the full world, okay, in this world A and B both are there. So if I calculate the probability of A and B, probably it would be 1. But if A is the world, okay, so that's why we say everything is condition. Okay, so if condition is bigger, then inside that A and B exist. And if condition is A itself, okay, then what is BA? So what we are trying to say? Okay, if bigger is the condition, then we can say that, okay, A and B are comprised in kind of in bigger condition. Okay, probably I can save it. Okay, now in bigger condition A and B, they exist. Okay, so in bigger condition A and B exist, and inside A there is a portion where B exists, and inside B there is a portion where A exists. So how we can kind of nomenclature give this portion? If I know A, if A is the condition, then what is the probability B inside A? If this is the condition, this full rectangle is the condition, then what is the probability of A and what is probability of B? If A is the condition, A is the big master, A is everything, A is 1, then what is the condition of B, probability of B being in A? Or if B is the master, B is everything, then what is condition of A and B? Okay, so suppose I know PA, probability of A, probability of B, so these are in global picture, and probability of B inside A. If A has happened, then what is probability of B? Considering B as a full world. If I consider full world is a real world, then what is probability of A and probability of B? If A being the full world, then what is probability of B inside A? If I know these, then what is probability of A inside B? This is orthogonal. This is what we are talking. So this can be considered as orthogonal case. Okay, and it is a kind of big thing. So being these two events, I would rather say, being these two events as orthogonal. Orthogonal means 90 degrees. Okay, so now these two are orthogonal in the sense now if I know PA, PB and A, B inside A, then what is A inside B? So, I mean, whatever we have discussed by now, so it is same thing in different discourse. So that whatever we see, same thing. But Mr. Bias is Mr. Bias. So in different discourse. So we know PA, we know PB, and if we know PBA, provided A has happened, and B, then what is the probability of BA? Okay. So this is the scenario. Now, if I see PA, okay, what is PAB? If B has happened, then what is probability of A inside B? Then it is probability of B, and then it is the PAB. So PAB is nothing but P intersection B by PB. So if I know P has happened, B has happened, what is probability of A inside that? Probability of B and their intersection. So this is what we know. Now, okay, so this is a general formula. Now we'll talk about this. So same whatever we have drawn, now same thing. Now intersection is clear. So this full white, whatever inside white is A, and whatever inside red is B, and whatever the intersection is from A's perspective, it is BA. From B's perspective, it is AB, and both are different. PBA and PABs are not same. So it is proportion as related to B. So B may be very big. Okay, and it is a proportion related to A. Okay, so if B is very big, then PAB would be small, and A is small, then PBA would be big. So these two are not same. They depend upon the size of B and A. Now we'll see the same formula. PA by PAB equal to PAB intersection by PB. Same as PBA and conditional PBA intersection. So if it is intersection, both are same. Now if both are same, then both sides we can equate, and then we can say that PAB equal to PB, PA, PBA and PA. Okay, so mathematics formula is formula. What is significance of the formula in the real world? So that is the idea, but we understood. So if I want to know probability of A in B's condition and probability of B in A condition, their intersection, and probability of B and probability of O divided by. This is what we saw. Means this is common sense also. And if I equate, then probability of A if B has happened conditional, and probability of B A has happened conditional. So it would be same, as these two intersections are same, intersection AB and BA, and then probability of A provided B has happened is probability of B separately and probability of A, and then inside AB. Okay, so this is the formula. We can draw as a tree also. Okay, that we'll see. So this is the bias theorem. How it lies in our concept of actor and sample space and selected item and division. This is what we have seen. Okay, so we'll add slides. These are local slides. Okay, so Mr. Bias theorem. Now, okay, so what is the question now? 15% blue and 85% red taxi in a city or at a place. Hit and run case in night. So someone hit and run. Eyewitness find taxi as blue. Eyewitness can make 80% of true assessment in night condition. Okay, if this is the scenario, then probability being eyewitness being true. Probability of eyewitness being true. Okay, so probability of Okay. Now probability of eyewitness being true. Okay, so if this is a scenario, okay, now can we see the blue taxi? Means the way we are drawing the items. Okay. Now can we see the blue taxi? So who is the actor now? If this is the case, then who is deciding the factor? Eyewitness. Eyewitness is the actor. How? Eyewitness is the actor. Okay. Now, as per the eyewitness, now the reality is gone. The way we are keep on saying here. Okay. So, like green color is whatever is the reality from someone's eye. Someone's eye. Okay. So, these are gone. These non-colored are gone. Only this comes into the picture. Okay. And inside that we have to find what is we want. Now, from blue text, now from eyewitness perspective, 80% of the cases eyewitness can find true, otherwise 20% is false. Now, if blue taxi is coming in front of eyewitness, all blue taxi, okay, 80% of it he finds correct. And this area, that is 20%, he is saying it is red or not blue. Now, red taxi is being brought, all red taxi is being brought near to him. I mean, whatever the sample is. And few he is identifying as blue. And rest he is identifying as red. I mean, he is identifying a big part as red, but few he is identifying as not red. So from, okay. So if I say, okay, or from this diagram, if I see the white color kind of circle or ellipse, white color circle and red color circle. So full white color circle is actual blue taxi and full red color is actual red taxi. But Mr. Eyewitness, part of it he is saying it is blue taxi, rest he is just discarding. Okay, so those scenarios are not coming into the picture at all. But in red taxi, few taxi he is identifying as blue and I mean it's not red and rest he is identifying as red. So anyway, red taxi we are not interested in. And here, even it is blue, but it is gone out of the scene. Now, as per the eyewitness, if I say eyewitness is true or not, now number of blue car, okay, I mean probability of the blue car. So if I say a number of the blue car, how many blue car that eyewitness is finding? Blue car in blue car. Okay, so how many blue car and blue car in red car? Red taxi. So blue car in blue and blue car in red. Now, what is the probability? Blue car in blue by blue car in blue plus blue. So, total blue he is finding. Okay, total blue is this region, and this region. So, this region is not into the computation. This region anyway it is not into the computation. So, total number of blue car that fellow is finding is, okay, some blue car in the blue and blue car in the red. So total blue car is blue car in the blue and blue car in the red. Then this is the kind of sample space. This is a sample item. And inside that we are picking this. Okay. So, now we are interested in this. Okay, so we are interested in this, whereas our sample space is this much and this much. Okay, so that is the calculation. So this is the actual basic probability, how basic probability works, the way we demonstrated. So this is the basic probability. Now Mr. Bias probability. Okay, so same question. Now the white circle, what we are saying is PA, and there is another circle called PW. PW is witness. So red car gone. This is Bayes' theorem. So there are two circles now. One is the blue car and one is, okay, the witness car. Okay. Now if that is true, then PA and PW, okay, two entity. And if we know the A, then what is the probability of W inside A? And if we, now what we want that provided Mr. Witness cars, okay, Mr. Witness is saying these many, identifying these many cars, inside that how many are blue? So PA by witness means if witness is the condition, then what is the probability of blue? So can we see it is different? Okay, so if we know that this is Mr. Witness car, all green color, and this is the blue car, so if the white color is the blue car, then that is PA, and if this is Mr. Witness car, that is PW. And if I know inside blue car, okay, if it is the condition is blue car, then what is the condition of Mr. Witness finding the blue car inside the blue car? And if all witness, as per the witness, whatever the blue car is inside that, what is the true blue car? So PA by W, we are trying to find where we know PA, we know PW, and PW by A. So this is Bayes' theorem. Okay. Now, if I see the PW, that is nothing but PA into PW by A. Okay. So it is PA and PW by A and PB in the sense we keep on talking PA and PB. PA and PB. So in this way, PB, okay, and W by B. So PA is blue and PB is red. So if I draw a tree, then A is blue and this is not A. So if in globally, if I see the 0.15 is PA, where 0.85 is red. Now inside blue, 0.15 into 0.8 is the blue that is witness is finding, and this it is he is discarding. Now inside red, this much witness is finding as blue, and this he is discarding. So now as per the formula, so it is PAW by A, PBW by B, and then it is above is the actual blue car. So that would be lead to 0.15 into 0.8, 0.15, 0.8, 0.85. So this is Bayes' theorem. Bayes' theorem brings probability in different world. Okay, where now if I talk about the orthogonal, keep on talking about orthogonal. So if I talk about orthogonal, okay, so now the actual orthogonal is Mr. Witness, means I would say like this, the blue car and another is Mr. Witness. So these two are orthogonal. Can someone believe this? Okay, now I have another example. Okay, example by example. Now there is a corona, 10% corona at a place, at a town, in a city, 10% corona, 90% corona free. This is the actual case. Now corona test confirms 70% of the corona positive in corona cases. Now if a corona patient is going for corona test, 70% chance as it will come as positive. Whereas a corona-free case goes for test, 90% chance that it will come as free, corona negative. Okay, it is true negative. I would say it is true negative. And it is true positive in machine learning technology. Okay, these are new things to kind of to deviate people. But anyways, now a person has been tested corona. Probability that he is corona case. Okay, he is a corona case. Probability that he is a corona case. Person has been tested corona. A person goes for test and he was tested corona. What is a guarantee probability that he is actually a corona patient? Okay. Now 70% of the corona tests are positive. So if he is a corona case, then high chance, but let's see the scenario. Now there are two circles. White circle is corona positive case and red circle is corona negative case. It means people are corona free. They don't have corona. Who is the actor as per? Okay. Now I have to really change. Okay. So who is the actor? So actor is corona test. Actor means hero. Hero means who changes the movie. Okay. So corona test. Okay. Corona test changes the movie. Whatever corona test result comes in, corona test is the hero. Okay, like earlier, eyewitness was the hero. If he is identifying 80%, scenario is different. If he is identifying 20%, if he is identifying 90%, scenario is different. Here, corona test is the hero. If corona test is 70%, confirm 70%, 90%, scenario is different. If it confirms 50% and 80%, scenario is different. So corona test is the hero. Now, among the corona positive cases, actual positive is this much, and these are coming as corona free. Fortunately, unfortunately. So we are not interested in this because we have to find that person as corona or not. So we'll go with the corona cases. If in a corona negative case, that means corona free cases, still there are chances that he will be tested corona positive because that is the test, that is the actor. Otherwise, it is corona free. Okay, now what we want? We want this. We want this. Okay. Actual corona patch means if he is tested positive. Now just see from the kind of eye of, if corona test is a kind of active guy, from that point of view, just see the world. Now what is problem in corona patient? How many corona patient he thinks? Corona positive in corona cases and corona positive in free cases. All are corona positive from the test perspective. And then corona positive in corona cases. This is what we want. This is what we want. By this plus this. Okay. So this is what we want. This plus this. This is the total cases. And among them we want this as percentage. So when we do deep analysis, just we have to find the actor. If actor is decided, then goal is through. Okay. Now let's see what Mr. Bias thinks. Okay. As per Mr. Bias, this is corona positive. And another circle is corona test, not corona free. Now, if corona test is conducted, PA by T If corona test is conducted, what is guarantee that he is corona patient? Okay, PA by T. Now I have to know the PA, I have to know PT, then I have to know PT by A. If A is known, how many people are corona patient, then inside that, what is the test? Okay, so what we are trying to find is, typos are there everywhere. Okay, so what we are trying to find is, okay, so we are trying to find A by T, so that is PT and probability of A and probability of T if A has happened. Okay, now if I see T, then PA same as in taxi case. Okay, and so we can draw a tree. 0.1 is corona patient, 0.9 is corona free, and again inside corona free 0.9 into 1, okay, is corona patient, and inside the corona patient 0.1 into 0.7 is corona patient, and 0.1 into 0.3 is free. Okay, so we are not interested in this, and we are not interested in this. We are interested in this one, and we are interested in this one. So this is bias theorem. Now PA, so that is this one. PA is this much, and PB is this much. Okay, so this is all about bias theorem. Okay, I mean, what we can kind of see is, everyone has its own eye. How you see the world. Okay. This is one eye of seeing the problem, and this is another eye of seeing the problem. But anyway, we'll go with whatever is the technology, whatever the technology is, and in future we'll see NLP, natural language processing, in machine learning. Okay, in future. And so what we achieved by now, that how we calculate the probability. First we understand the problem in depth, and we find the actor, Mr. Actor of the movie. Once actor is identified, then we create a complete space, and based upon the actor's eye, we find the sample space. Once sample space is decided, then we pick the item what we want, and then we divide what we want by total sample space seen by the actor. Okay, so bias theorem is same thing. So bias theorem is another way of what we describe. So if there are two orthogonal items, what we see, white and red exists in white and white exists in red, and if we know both probability, independent probability, and one conditional probability, what about the other conditional probability? Okay, so if this is the formula, then we deduce the other conditional probability is nothing but whatever the condition we are looking for, that condition, that probability, independent probability of the orthogonal one, and if orthogonal one exists, then what is the probability of be that condition what we are looking for. So that is the bias theorem, where bias theorem can be deduced through the tree structure. Okay, so from the real basic, the probability way, we saw that. So here, if a coin is tossed 3 times, then triple tossing, that is the actor that decides the actual picture, and in actual picture we find the whatever we want. And in a bag, if there are 2 green, 3 red and 2 blue balls, then actual actor is dual ball, because dual ball decides the scenario. and in the scenario we pick what we want and then we divide it. We calculate this by combination, not permutation. Okay, then we went to Bayes theorem. So if this is the case, like blue and red taxi and blue taxi is making hit and run case, as per the eyewitness, where eyewitness is only 80% true, in that cases we find from the eyewitness, from the actor's eye, we find the sample space. So this is the sample space plus this is the sample space. So cross is gone and total sample space, what we see, and whatever we are looking for, we divide. Same thing what we did. Total sample space plus what we want. Okay, through Bayes theorem takes us into different world. So blue car is okay, blue taxi is okay, but witness I came into the picture, and then we say that I know PA, I know PW, witness, PAW, then I have to find if W is there, then what is A? Okay, in another case, a city is 10% has 10% corona, 90% corona free. Okay, corona, if 70% corona positive case, if person has the corona, 90% corona negative if doesn't have corona. So sample space is this much and this much. So both places, corona free places and corona case, both where corona patients are there. From the actor's eye, corona test is the actor, from actor's eye. If that is the case, then total sample item plus what we want. Now from the Bayes theorem, we see two orthogonals. Okay, so one orthogonal is, I think we drew it. Okay, we drew in other way. Okay, anyways, same case happens here also. So okay, so two orthogonal, one orthogonal and other orthogonal. Okay, so here also two orthogonal. One is test, that is the actor, and another is whatever we see, corona patient. And same scenario arrives, test is down, and we have to find if test is conducted, then what is the scenario of the corona patient, being a corona patient. So finally we came to tree and we calculate the number of corona patient as per the test and what are the actual. Okay, so that is the Bayes theorem. Okay, so we'll see NLP later.